Today we will be solving a few problem sums based on square, square root, cube and cube root which are of level 2. So let's start the class. The first problem sum says a man purchased a plot which is in the shape of a square. The area of the plot is 12 hectares and 3201 meters square. Find the length of each side of the plot, and that too we have to find in meter. So since the area is given in hectares and meters square, both the units we have, and finally the length of each side of the plot we have to find in meters. So in the beginning what we will do is we will convert hectares in meters square. We know that 1 hectare is equal to 10,000 meters square or square meter. That means area of the plot will be, so the length of each side of that square plot will be what? The length of each side will be square root of that, since it is square plot, so it will be 351 meter. The second sum says the least positive integer with which 661.25 should be multiplied so that the product is a perfect square. So the given number is, that means 66125 divided by 100. Now 100 is a perfect square which is square of 10. So now we will evaluate this number 66125. Definitely, as per the given problem statement, this is not going to be a perfect square, and there will be a deficiency, and we need to find that value by which we will multiply this value so that the final value will be, a final number will be a perfect square. So to solve this type of problem, what we do is we factorize that given number. Then only we can find that how much or what is the factor or how much is the value that is deficient. So if we look at this value 66125, we can see here this is a product of 223 and 35. So 23, since we have 2, that is in even number, and 5 we have in odd number, we have 3 5 here. So if we multiply this number by one more 5, then that number will be a perfect square. So as per the problem statement, we need to find that value, that least positive integer, because other than 5 if we can multiply by 125 also. 25 multiplied by 5 is 125, and 25 is also a perfect square. So that number will be again a perfect square. And if we multiply by 5 5, then also that number will be also a perfect square. But we need to find least positive integer. So least positive integer means single 5 we will multiply by. So to make 661.25 a perfect square, we need to multiply that value by a single 5. Now the next sum says the units digit of the square of a number, that means digit at units place of a square of a number, and the units digit of the cube of the number are equal to the units digit of the number. How many values are possible for the units digit of such number? Now this is the list where I have, in the first column I have written the numbers, and in the second column their square values, and in the third column their cube values. Now what we can see is the number is 1, means at units place the digit is 1, and square value also, in the square value the digit at units place is 1, in the cube value also that is 1. So this is applicable. For 2 at units place in the square value it is 4, and for cube it is 8. So this is not applicable. For 3 also 9 and 27, that means at units place it is 7, and here it is 9, so not applicable. Again for 4 it is 16, so at units place it is 6, and here it is 4, not applicable. For 5 it is 5 at units place in the square value, and in the cube value also at units place it is 5, and in the number also at units place it is 5, so this is applicable. For 6 the number is 6, here at units place the digit is 6, here at units place the digit is 6, so this is also applicable. For 10 at units place the digit is 0, and here in the square value also it is 0, and in the cube value also at units place the digit is 0, so this is also applicable. And as per the problem statement, we need to find how many values are possible for the units digit of such numbers. So at units place the digits will be 0, here 1, 5 and 6. So that means this type of 4 numbers are possible. Now the next question, when 616 is divided by a certain positive number which is 66 and 2/3% of the quotient, it leaves 16 as remainder, find the divisor. Now 616 is divided, so 616 is the dividend. Now when it is divided by certain positive number, which is 66 and 2/3% of the quotient. So here the quotient is not known, divisor is also not known, but the remainder value is given, which is 16. So let's assume that the quotient is x. So if quotient is x, then the divisor will be 66 and 2/3% of x. So that means it is 198 plus 2, 203, and percent, that means by 100 of x means this. So that means divisor will be 0, 0 will cancel each other. So divisor will be 2x divided by 3. And as per the statement, the remainder value is 16. Now we can write this way. We know that if a is the dividend, b is the divisor, and q is the quotient, and r is the remainder, then, and as per Euclid's lemma, we can represent this way. So dividend is how much? Dividends is 616. B is what? B is the divisor, which is 2x divided by 3. Quotient value we assumed as x, and remainder value that is given as 16. Now this is a quadratic equation of x. Now if we simplify further, then it will be 2x squared divided by 3, and this 16 we can take this side. So 616 minus 16, it will be 600. So it will be 300. That means here we have 300 means 3 multiplied by 100 and then multiplied by 3. So x will be how much? X will be square root of x. So if we take the square root value of this, then finally this value will be 30. That means the quotient value will be 30, and the divisor we need to find. So divisor value will be how much? It is 2x divided by 3. So 3 means 10, and divisor will be 20. Now the next sum, if a and b are whole numbers such that a to the power b is equal to 512. So a to the power b is equal to 512. Also some more conditions are given where a is greater than b, fine, and b lies between 1 and 4. So it's greater than 1 and less than 4. That means possible values of b could be either 2 or 3. Then what is the value of b root of a? So a to the power 1 by b, this value we need to find. That means separately if we can find the values of a and b, then we can easily simplify, or we can easily find this value. So 512, apparently we know that is 2 to the power 9. So if we compare these two values, then we can say a is equal to 2 and b is equal to 9. A is equal to 2 is okay, but b is equal to 9, that doesn't satisfy both the conditions, because here a is greater than b, so 2 is greater than 9, which is not true. And also b is either 2 or 3, because it lies between 1 and 4, so that is not possible. The another combination, a to the power 512, that we can write as 512 to the power 1. So 512 in that case will be a, and b will be 1. So a is greater than b. So first condition is getting satisfied, but the second condition, so it is not being satisfied here. So these values are not possible. Now the third possibility is a to the power b is equal to 512. That can be written as cube of 8. So cube of 8. Now if we compare these two values, then we can say that a is equal to 8 and b is equal to 3. So a is 8, b is 3, means the first condition a greater than b, that is getting satisfied, and the second condition is b will be either 2 or 3. So that second condition is also getting satisfied. That means this possibility is valid. So a is equal to 8 and b is equal to 3. Now we need to find a to the power 1 by b. Now a is 8 and b is 3, so 1 by 3, and 8 we know that can be written as 2q, and then to the power 1 by 3. This 3 and this 3 will cancel each other, and final value will be 2. Now the next question. Now as per the statement, what is small q? Small q is the semi-perimeter of that triangle. Now x, y, z, these are the three sides of that triangle. So if we add them, then we will get the perimeter. That means the semi-perimeter will be x plus y plus z divided by 2. Now x plus y minus z, which is equal to 4. Also y plus z minus x, that is equal to 4. And the third equation is what? Z plus x minus y. z plus x minus y, that is also equal to 4. By doing 1 plus 2 plus 3, what we get? X plus y plus z, that is equal to 12. So what is the q value? The semi perimeter, that will be 12 divided by 2, that means this is 6. Now if we further simplify this, then it will be q, and in place of q, if we replace q by this value, x plus y plus z divided by 2 and then minus x, and similarly, so it can be simplified this way. Q, I am keeping that as q only, and this first term will be simplified like x plus y plus z minus 2x. So plus x and minus 2x, it will be minus x only. So y plus z plus minus x divided by 2, that is 4. So finally this value will be 4 divided by 2, and q is how much? Q is 6, that we have already found out. So 6, and here it will be 2, here it will be 2, here it will be 2, and then square root of that. So it will be 2 2's, and then it will be root 3. That means finally it will be 4 root 3 square in square unit. Next we have 1 plus 3 plus 5, and till 53 we are adding all these numbers, and of that result of addition we are taking the cube root. That value we need to find, and that we can do without doing the real addition. So if we look at this, 1 plus 3, what is that value? 4, and 4 is what? It is 2 square. Then 1 plus 3 plus 5, 1 plus 3 plus 5 is how much? It is 9, and that is 3 square. So we can say here that when we add first n odd natural numbers, then the result of that addition is square of that number. So when we are adding first three odd natural numbers, then it is 3 square. When we are adding 2, then it is 2 square. Then again if we look at the first 4, then the result will be 16, and 16 is 4 square. So when we are adding first 4 odd natural numbers, then the result of addition is becoming 4 square. So this is one of the properties of square numbers. So if we now look at the values, it is from 1 to 53. 1 to 53, if we don't know that how many odd natural numbers we have, but 1 to 52 if we consider, then within 1 to 52, within that range, we know we have half odd numbers and half even numbers. So 52, if it is the final number, last number, then 52 divided by 2, it is how much? It is 26. That means from 1 to 52, we have 26 even numbers and 26 odd numbers. Now the next number is 53. So 51, till 51 we had 26 odd numbers, and then we have one more odd number, which is 53. That means here within this series sum, we have in total 27 odd numbers. So this is basically summation of first 27 odd natural numbers, and as per the property of the square numbers that I have said just now, it will be square value of that number. So it will be 27, square of 27. So it will be 5 to 9. Now the next sum and the last sum of this class, root x plus 58 by root x is equal to 31. Then what is the value of x? Now this type of problem we will simplify by using this trick. Here root x plus 58 by root x is 31. That means this value, the result of this addition, is an integer. So basically we will be adding two integer values to get the final integer. So root x is an integer, and 58 divided by root x is also an integer. So 58 divided by root x, since that is an integer, that means root x can be said as one of the factors of 58. Then only 58 divided by root x will be an integer, because 58 if we divide by 2, then that value will be 29. So 29 is an integer, where 58 if we divide by 2.5, then that value will not be an integer, that value will come in decimal or fraction. So that result of division 58 and root x to be an integer, then root x has to be a factor of 58. Now let's factorize 58. That means 58 has only two factors, 2 or 29. Now if we take root x value as 2, then it will be 2 plus 58 divided by 2, and that has to be 31. So this is 2 and 58 divided by 2 is 29, and that is equal to 31. So it is satisfied. And the second value, now root x value if we take as 29, then it will be 29 plus 58 divided by 29, and that has to be equal to 31. So it is 29 plus 2, that is equal to 31, and that is also is being satisfied. So the value of root x either can be 2, or the value of root x as per the problem statement can be 29 also. That means x will be equal to 2 square, which is 4, or x can be equal to square of 29. So the final value of x will be either 4 or 841. Now there will be a small correction in the previous question. We needed to find the cube root value of this summation. So this summation we represented as square of 27, which was 5 to 9. So finally if we find the cube root value, then it will be 27 square and then cube root of that. Now 27 can be represented as 3 cube. So 3 cube, and then already we had a square of that, and then outside of that we have a cube root. So this 3 will cancel in the power. So finally it will be 3 square, or that value will be 9. So this will be the final answer, 9. So I hope this class was helpful for you. With that hope I end today's class. Thank you.